How do you return values from methods in Java? Why do you return values from methods in Java? And how do you write input validation methods? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 28th video in the Introductory Programming in Java full course and the third video of Lesson 5, Static Methods in Java. In the first video of this lesson, we looked generally at static methods in Java, and in the second, we took a deep dive into parameters. Today, we're going to look at value returning methods in detail. Let's get right into it. Understanding methods and learning to write them properly requires a fundamental shift in the way you think about your programs. Before methods, our programs interacted with the user. Inputs came from outside the program through the keyboard or a file, and outputs were sent outside the system to the console, where they would appear on the user's screen. To design properly with methods, you must imagine your programs as encapsulated components taking inputs from each other and sending each other results. In my experience, this is a difficult conceptual shift for most learners. It might be easier to learn if you anthropomorphize the system a little. Think of each method as having human-like properties. Then it's not just you, the programmer, talking to the user. It's your main method, asking your pose question method to pose the question and get the user's answer, and your pose question method sending A, B, C, or D back. Maybe one or two of your methods will interact with the user, but then they take what the user has given them and pass it to other methods to transform it in specific ways before producing a result for the user. This is the divide and conquer principle, and once you get the hang of it, and you will, it'll make designing software a lot easier. We'll talk about that in more detail in a future video. Let's look at an example, and we'll focus on the values returned by methods. This program is called AImethods.java. It's based on the AI Reader program from a video in the last lesson, in which we learned how to read from a text file. I've chosen this program because a text file gives us a lot of data to work with without the user having to type it in. Let's run AImethods.java first. When I run it, I'm presented with a menu asking me to choose from 3 different analyses of the data, or if I type 4, the program will quit. I've actually only implemented one of these functions, the year average. If I choose 2 or 3, you can see the program tells me this option is not yet implemented, and it presents the menu again and asks me to choose. I'll choose 1, and I'll enter the year 2017. I see that the average AI spending for 2017 is approximately $1 trillion. I'll choose 1 again and enter the year 2018. And I can see the average AI spending for 2018 is $1.7 trillion. Okay, I'll choose 4, and the program stops executing. Now, let's take a look at the code. The main method is the method that interacts with the user. It presents the menu to the user inside a do-while loop on lines 103 to 107 and obtains the user's choice. It handles the user's choice in a switch statement that handles each menu option except quit and simply ignores bad inputs. If we look at the code for handling choice 1, average spending for a year, you can see that the year is obtained from the user, and then we invoke the method average spending, passing in the file name and the year the user's interested in. The average spending method opens the file and loops through, reading each 3-line record and totaling spending values for years that match the year passed as a parameter, and also counting them so it can compute an average that it then returns. This code is so similar to the code in the prior video that I'm not going to go into it in detail. If you want to review how to read from a text file and apply our looping algorithms to file input, please watch that video. I'll link it here and in the description. In this video, the focus is on returning values, so let's look closely at how that works and why the solution is structured the way it is. You can see in the method header, we begin with public static double. After the modifiers public and static, we put the return type of the method. If the method doesn't return any values, then we put void, as we do with main. But if it's returning a value, we put the return type. This can be a primitive type, like double, as we have here, or it can be an object type, a class. For example, we could have a method that creates a scanner that points to a file and returns the scanner. In that case, we'd put scanner as the return type. So the return type is any type, just as when we're declaring a variable. At the end of our method, we should then have the keyword return followed by an expression that evaluates to that type. There's that word expression again. Remember, an expression is a construct made up of literals, variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value. So just as we can pass a simple expression, like a literal or a variable, as a parameter, we can return a simple expression, such as a literal or variable. Or we could return a more complicated expression, such as a calculation, just as we can pass more complicated expressions as parameters. You'll find experienced programmers do that quite a lot if there's no reason to store the result of an expression in a variable, if we only want to pass it as a parameter or return it as a return value. In this method, we're returning a variable, average. That variable will either hold the average, or it will hold 0 if there was no data to average. Depending on our method specifications, we might want to return a value like -1, something that wouldn't be a natural result of average bending, to indicate there was no data. Here we're just returning 0. I could return a more complicated expression here. I could remove my if statement on lines 65 to 67. And instead of writing return average, I could write return num records greater than 0, question mark, expenditures, divided by double num records, colon, average. That would have the same effect, but I'm not sure that's more readable. It's just an example of returning a more complicated expression than a variable. You might remember I said parameters being passed are like assignment statements. For example, in this method, the parameters are file name and year. And where I'm invoking this method, I'm passing in the literal AI investment.text and whatever value the variable year evaluates to. Let's imagine the user typed 2017. Then that's equivalent to file name equals AI investment.text and year equals 2017. The actual parameter expressions are evaluated and the resulting values are assigned into the formal parameters. It's very similar with return values. Whatever a method returns is evaluated, and that is what the method call evaluates to. So if average spending returns a value around 1 trillion, then back where we're calling this, the method call average spending AI investment.text year evaluates to around 1 trillion. If we want to use that return value in the calling method, we're going to embed it in an expression. Here, it's on the right side of an assignment statement, and this is quite common. So average equals, and then whatever the call evaluates to, such as 1 trillion. You must do something with the return value from a method call if you want to use that value. It's the way the method returns its work to where it's called from. Remember that methods are like Las Vegas. What happens in a method stays in the method. This property, called scope or visibility, will be the topic of the next video. So if we want the result of the method's work, it must return the result, and we must embed the method call in an expression, such as an assignment statement. Again, it might help to anthropomorphize the method components. The main method is a little person who asks the average spending little person to average the spending found in AI investments for the year 2017, for example. And the average spending little person does that work and writes 1 trillion on a piece of paper and hands it back to the main little person. I don't know why they're little. In my imagination, I guess they live inside the computer. Now, main can use that result. In our example, main is printing it for the user. But you've seen plenty of examples where we've done other things with the result of method calls. For example, line 109, choice equals standardin.nextInt, is a method call that returns the value the user typed at the keyboard converted to an integer. And we assign it to the variable choice and use it to control our switch statement. Now, before we write an input validation function, I want to just mention that best practice, in most cases, is to have one return per method. This is primarily for readability, but remember that readability also includes debuggability. A method stops executing once control reaches a return statement, and control returns to where the method was called. So if you have returns embedded within the method, it might look like code is executing that isn't actually executing because it's after a return. It's as if control is jumping out of the middle of a method when we generally expect methods to execute start to finish. And it's just going to be harder to follow that flow of control. So you can have a variable that's your return expression and set the value of the variable in multiple places, like I'm doing here. Then return it once at the end. You definitely don't want to use returns because you can't figure out how to structure your method without them. Don't use them because you want the method to stop executing in the middle. Use if statements to prevent executing code that shouldn't execute, not returns. Okay, now let's write an input validation method. An input validation method is going to take input as a parameter and return true or false. You can write it so it returns true if the input is valid and false if it's invalid, or vice versa. Let's say we want to validate the user's menu choice. So instead of ignoring a value that isn't 1 through 4, we're going to tell them they need to enter a value that's 1 through 4 and get their input again. We've written input validation loops before. Let's write the loop first. On line 109, I'm obtaining the user's menu choice. That's the initializer for the loop. Then I'll write while. And after the while, I write the condition for bad input. Good input is choice greater than or equal to 1 and choice less than or equal to 4. So bad input is the complement, choice less than 1 or choice greater than 4. So while choice is outside of range, I'll print a message. Your menu choice must be 1, 2, 3, or 4, and then the updater. I'll prompt and read the input again. Okay, so that's an input validation loop. It traps the user in the loop until they give us a valid response. Sometimes it's more complicated to validate input and can't be done in a single logical expression. In those cases, we have to write an input validation method. But even with a relatively simple loop entry condition like this one, an input validation method might be a better choice. An input validation method can be more readable. And if you have to add conditions for validation in the future, it will be easier if you've already got the validation in a method. So it will make changing the program in the future easier. Let's replace that condition with not valid menu choice choice. So our loop header reads, while not valid menu choice, which tells us exactly what this loop is doing. And let's write the method. Public static boolean. This is going to return true or false, valid menu choice int choice, and then we could write return choice greater than or equal to 1 and choice less than or equal to 4. If you prefer to do it with an if statement, write boolean valid, and then if choice greater than or equal to 1 and choice less than or equal to 4, valid equals true, else valid equals false. Or you can do this with the conditional or ternary operator, or you can set valid to false by default and then only change it to true if the input is valid. There are a lot of ways we can set the variable, and then we return valid at the end of the method. However we choose to write it, the method is going to return true for a valid menu choice and false for an invalid menu choice. Now, back where it's called, we can write simply not valid menu choice choice because the method returns true or false. Remember that that return value is what the method call evaluates to. So valid menu choice is going to evaluate to true or false, and the not in front of it means not valid. We want to go into the loop when the choice was not valid so we can get another choice from the user. If I run the program now and enter 0, 5, -1, notice I get the message and have to enter a new value until I enter a valid value. Let's enter 4 so the program will quit. Now, I hope this is all starting to congeal for you. There are a lot of similarities between passing parameters and returning values. Returning values is basically like passing parameters, but backwards. In fact, in some languages, such as Pascal, Fortran, C, C++, Swift, and Rust, you can have parameters that are for returning values. So it's exactly the same. As usual, I have included an auto-graded exercise in the description of this video so you can practice with the input validation method. And the program has been uploaded to my GitHub repository with a link in the description. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.